Welcome back. Today we are solving an IGCSE Mathematics question from 2023. This is a tricky question as it's worth 4 marks and they give us a triangle. It's a strange triangle, making this a trick question. So calculate the obtuse angle. Over here they've told us that it's obtuse, which means the angle is going to be greater than 90 degrees. So PRQ is going to be greater than 90 degrees, which will be important to us later. So angle PRQ, the angle over here, is supposed to be greater than 90 degrees. Alright, so let's take a look at this triangle here. We have an angle, and we have an adjacent side, and we have an opposite side. But we don't know this is a right angle triangle. We don't know that yet. So we have to assume that it's not, and then use something like the law of sines or the cosine rule to solve for PRQ. Now angle PRQ can be solved effectively with the cosine rule without any mistakes, because you will be solving a quadratic, and that quadratic will give you 2 solutions. And the reason you get 2 solutions, one is an acute angle, one is a obtuse angle. You get the 2 solutions because this is an ambiguous case for the sine rule. If you just use the sine rule, you will get an acute angle and you'll get the question wrong, unless you think about the triangle like this. So QR is 13.5 centimeters. So this length is fixed, whereas PR can be any length. In fact, we can extend this line infinitely to make a new triangle, and you'll understand why in a minute. So PR is this infinite line. We don't know its length, so it's infinite. Now if I swing 13.5, that line QR, I can swing this over to another point, maintaining the same length, because I don't know this angle. I don't know the angle RQP. PQR, I don't know, which means I can swing that angle. I can swing this 13.5 centimeters in any direction I want, and as long as it intersects PR at a point, it's a valid triangle. And this is where we get our 2 solutions from. So this acute angle is over here. So let's imagine this is R dash, a new position for R, a new possible position. So we have 13.5 centimeters over here. These 2 lines are equal. QR dash is equal to QR. So we have an isosceles triangle, and let me draw a perpendicular line here. Just a dashed line real quickly to show that this is an isosceles triangle, and the base angles of this isosceles triangle are going to be equal. That's a rule you need to learn. Now, we know that R dash RQ is going to equal to R dash Q. And since these angles PRQ and PR-Q are on the same line, we can say that angles on a line add to 180 degrees. So if R-Q is theta, then we can say that angle PRQ is going to equal to 180 degrees minus theta. So angle PRQ, that's an R. So angle PRQ is 180 degrees minus theta. Now there's another way to think of this. If we have a sine wave, now the range of the sine function or the inverse sine function is between negative 90 degrees and 90 degrees. So you will miss out on the obtuse angle if you use the sine rule. Now, even with the sine rule, we can say that, oh, my line intersects with the sine wave at 2 points, over here and over here. If we use the inverse sine function, we will get this over here because this is less than 90 degrees. That's going to be theta. Now, since the sine wave is symmetrical in some ways, if this is the 180 degree mark, we can say that 180 degrees minus theta will give us the other point of intersection. Right, so the same thing is going on here. 180 degrees minus theta is equal to the angle PRQ. And over here in the diagram, we can see that the line QR and the angle PQR can work together to swing and produce two different triangles. Okay, so let's look at the sine rule. By the way, this type of triangle is called an as triangle. Angle, side, side. Because you have an angle here, you have a side here, and you know another side here. And in this case, since the opposite side is shorter than the adjacent side, and this angle over here is acute, we get two different triangles. More specifically, we know that 13.5 is greater than the sine of 42 degrees times 18. So that's why you get this swinging side. Otherwise, you just get a perfect right angle triangle. So looking at the sine rule, we have sine of theta over sine of theta, which we don't know yet. And the opposite to the theta is 18 centimeters. So the opposite side to theta will be 18 centimeters long. So the sine of theta over 18 will equal to the sine of 42 degrees all over 13.5. Now if we just rearrange this equation by multiplying both sides by 18, we get the sine of theta equals 18 times the sine of 42 degrees all over 13.5. Then we can take the inverse sine of both sides and we get theta equals sine inverse of 18 times the sine of 42 degrees all over 13.5. So using our calculator, we get theta equals 63 degrees, well 63.1 degrees. Okay, because we have to round our angle to 1 decimal point. So we look over here, we see 108 degrees minus theta is equal to the angle PRQ. So we know that angle PRQ is equal to 180 degrees minus 63.1 degrees, which is 116.9 degrees. So the answer is 116.9 degrees, and we can see that it is obtuse, obviously, because it's greater than 90 degrees. And that's how you solve this question. You get full marks for showing that you use the sine rule, and you get another mark for arranging this fraction, solving this equation, and then recognizing that 63.1 degrees is acute, and then getting the final answer also gets you that mark. So this question is easy if you know what you're doing. If you know the ambiguous case, it's easy. You could use the cosine rule, but that is much longer. You know, you can get a squared plus b squared minus 2ab, etc., etc. But this is faster and time is precious. So good luck, and I hope you learned something from this video. Please subscribe if you found this video helpful, and don't forget to like the video. Thank you.